Question number 4 of the PhilNITS FE afternoon portion of the exam. In this question, we are given a function called SUMDIGITS, which receives a non-negative integer value num as argument and returns the sum of the digits of num. Okay, I think we need to come up with an example so that we'll be able to understand clearly what exactly we need to do. And if we do, for example, come up with a number like 1, 2, 3, 4, 5, so that is 12,345. The sum digits function should give us the sum of 5 plus 4 plus 3 plus 2 plus 1. So that's the function, the output of the function that we should be able to arrive at when we put the number into the sum digits function. And the question, I think, shouldn't be too difficult, except that when I was answering this, I ended up with the incorrect answer. And to explain a little bit how I arrived with the incorrect answer in this case, I think we, of course, would need to look at the answer group. So from the answer group, we can see that there are two columns because there are two blanks, and the program would need us to put in the answers for the two blanks, A and B. And I think when I was looking at the answer group, I immediately thought that this integer part of parentheses number divided by 10 closing parentheses is the correct answer for B, except that when I moved to A, I may have thought that it would still be integer part of parentheses number divided by 10 closing parentheses and just add it to the sum so that we can eventually arrive at the total sum when you add all the digits, except that if we try it out and see whether it would really give us the correct answer, we'll find that this won't give us the sum of the digits of 12,345. And therefore, I think that if you have come up with an idea, you should definitely try it out with a few numbers. For example, if you have more time, maybe more numbers, because sometimes the idea would work up to a certain number, but eventually it will break down. And so there are cases when you need to try out more numbers. But in this case, if you have a bit of time to try just a few numbers, you may find that F is actually not the answer that you should be going for, because it turns out that the correct answer is letter B. Now we need to know why it's letter B, and if we look at the program again, we have here the function called SUMDIGITS, and the sum is currently at 0. It's an integer, which means it's a whole number, no fractions or any of the sort. And we go through the loop, the while loop here, and if we are sure that number, the answer for column B, or blank B in this case, is integer part of number divided by 10, then really we need to figure out what the answer for letter A would be. Now, just to see why integer part of parentheses number divided by 10 closing parentheses is the correct answer, let's look at what happens when we divide by 10 a sample number that we can come up with, like for example 12,345. Remember that if you multiply this by 10, you'd get something like this. It will be 123,450. The 0 is simply added to the end when you multiply it by 10. But what if we divide it by 10, which is what we're doing here? Then we would have to shift the decimal point from the right to the left. So that would give us 1234.5. So if we are doing the division here, then we are moving the decimal point towards the left side from the right. And from there, we can get hold of the number incrementally, which means that we should be able to get only, for example, 5 and then 4 and then 3, each one by one. Now the question next is, if you divide it by 10, you get 1234. How do you get the 5, right? And the answer to that is, if you, for example, have got 1234, you multiply it by 10, and that's where you get 12,340 here, and then subtract that to 12,345, which would give you 5, which is the remainder. And that's really how mod supposedly works, because remainders, if you're dividing by a certain number and the number as output gives you a remainder, then that would be the output for mod. For example, if you have 1 divided by 2, which translates to how many 2's are there in 1, we'd say 0, because it's 1. You need another 1 to get a 2 here, so that it becomes 2 divided by 2, and that's when you can say, yes, how many 2's are there in 2? You'd say there is 1, right? But in this case, because there's no 2 in 1, then you say that um, the number of 2's in 1 is 0, and so instead what you get is a remainder, which is 1. Okay, and in that sense, in this case too, we get 5 as the remainder. Now if we are to do this incrementally so that we get all the digits, then what we get would be something like this. We divide it by 10, and then we get the 4 here, and because this is the remainder, and remember that actually what we're doing is mod, not divide, although divide is part of what we need to get hold of the value from mod. Then gradually we are getting the 4, the 3, the 2, and the 1, right? As you can see, we are moving the digits so that we can get hold of the digits of the input, the number, one by one, and then we'll add all of them. And in this case, what we need to add is the part here, the remainders. So 4, 3, 2, 1, those are the remainders. That's the set of numbers that we need to add. And the mistake that I had was I got the one on the left side, and I added those instead of the one on the right. But if we did add those, the sum that we'll get would be 4 plus 3, that would be 7, plus 2, let me see if I'm getting it right, plus 2, and then plus 1. So that should give us 10, not exactly 15. So therefore, the sum, if we add all the numbers, here should give us 10. Oh, I think it's because this one doesn't include this one yet. So plus 5, then that would give us the 15, which is the correct answer for the sum if our number as input is 1, 2, 3, 4, 5. Okay, so again, the correct answer is letter B.